Make them freeze up on the board.
Powertrain Fundamentals Test 5.
Maybe. Hey. Driveline.
5.
7.
Yeah, basically this course used to be called Powertrain Fundamentals. Now it's called Drivetrain.
Turn that neon off?
Drivetrain, huh?
Yes.
Switch it off. Yeah. And come back in here. Okay, this is some simple questions that the people that have been in transmission should be able to answer this off the top of your head with no problem at all. Some friction disc or steel on both sides and have no friction material. That's actually true. Yeah. Basically, because you got fibers and steels. All in a clutch. Some of them are got lining on them, some of them don't. Well, what do they do though? You got to have friction there, or they won't work. Now they got to have friction disc next to them, but they're still considered a friction disc.
Okay, but this says some friction discs are steel on both sides and have no friction.
Yeah, you know how you got a fiber and a steel and a fiber and a steel and a fiber and a steel. Every other one is just a steel, and the fibers have got teeth on the inside, and the steels have got teeth on the outside. And so basically it's still a friction disc because it depends on friction to do its work. See what I'm saying? That's what
one was true?
Number one is true, yeah. A bushing is a type of bearing.
Education. True.
True,
yeah. That is true. And why do they call a bearing a bearing?
It bears all the weight of the world.
It bears, yeah, that's a good point. It bears a load. I asked George Gonzalez whenever he was in here one time, that little boy that spoke Spanish. I says, George, what is the Spanish word for bearings? And he says, I don't know. I've never had to say that word in Spanish before. So I had to look it up, and it's rodamientos or something like that, but he just never had to say bearings in that language, which was interesting because they're words we don't know. If somebody asks you, how do you say whatever? The clutch is operated by mechanical pressure. Is the clutch operated by mechanical pressure? That's a strange question, isn't it? The clutch is operated by mechanical pressure. Does that mean you released it by mechanical pressure, or it requires mechanical pressure to work? Or see, now that's a question that came from the textbook publisher. That is the dumbest fool question that I think I've ever seen. If I ever saw a question like that on an ASE test, I would want to file a grievance or something, But that's a terrible question. Just put false on that, and I'm going to go on past that. I don't know what in the world they're talking about there. I've took about 746,212 ASE tests, and I ain't never seen nothing like that on there.
That's a lot fancy.
A roller clutch, I know, I was sort of being hyperbolic. A roller, did y'all get it back? Did you get it brought back? Okay, you didn't leave it parked somewhere and walk back, did you?
No.
Okay, we're on question. Grab your drivetrain test 5. We're on question number 4. A roller clutch is a two-way clutch. Is a roller clutch a two-way clutch? Now, a roller clutch is like a sprag. A sprag. A sprag has got little bow tie shaped things in it, but a roller clutch does the same thing. Yeah, you're correct about that. It actually the balls, they actually roll on a little ramp, so that when you turn it one way, they roll into the deep part of that ramp, and then when you turn it the other way, it'll roll up out of the ramp and it locks the center. So it's a one-way clutch. Basically, is what it is. That's one of the kind of clutches you got in automatic transmission. A worn or warped drum surface, the drum being where the clutches and steels are, can be visually inspected. There will be times when you've got one that's worn or warped that you cannot see what's wrong with it with the naked eye. So when that's why I love these transmission guys. The cool thing about working in a transmission shop, if you've got a lot of transmissions that you've done a lot of, or an alternator shop or anything else, is you've usually got some parts laying somewhere that you can try. Remember we was fighting with Abby's transmission, And I said, well, this part right here, we couldn't see anything wrong with it, but it just flat wouldn't work right. You remember that center part? And so, and it's really surprising how cheap you can get stuff like that. So I called Adams over there, and I said, I need that centerpiece, that goes in that AX4N. I described whatever the name of it was, I don't remember now. And he says, yeah, I got one of those that built up with new clutches in it and everything for $75. I thought, that's pretty doggone reasonable, because it's got all that hardware in there. And he didn't even want the old one back. But when it got over here, somebody else had built it and, sold it to him, and he sold it to us. And it had some parts missing out of it. So we sent it back over to him, and he said, oh, yeah, it's got to have his washer and all that stuff they left out, and we put those back in there. And it was that, and it was the solenoids that we put on there that cleaned that thing up and got it working, And Daniel and Webb thought they had slayed a dragon when that thing shifted right, didn't they? They felt like, that's what I told Daniel. I said, you keep working on that thing until it's fixed, you're gonna feel like you won a fight. You know, and a guy, I tell you what'll beat a guy up is if you've got a guy that's working on something and he's working and he can't figure it out, and he has to go home at night and that thing still ain't fixed and he can figure it out, you feel defeated, don't you? You ever feel that? I just feel beat up, you know. But I tell you what, if I've worked on something and I've beat my head against the wall and finally figured it out and I know that sucker's right, man, I feel 10 feet tall. Hey man, I want to go out and get something to eat and watch a movie when I get home. You know, I don't care if I can stay up till midnight. And I feel like a new man. But I mean, you go home and you can't figure that thing out. Even if you hadn't really worked all that hard today, you just feel like you're a little beat under. So that's why I got a lot of times get you guys to you need to have some success to build your confidence. You see what I'm saying? So sometimes they give you a big job that you got to plow into it and, you know, beat the thing. And that's part of the deal. You feel like you, yeah, yeah, you got to do something. You know. All right, so here we go. Piston return spring needs to be removed before the piston can be serviced. Where's the piston? The ones of you that have had transmissions know where the piston is. And a transmission now. This is not a piston in an engine. Where is the transmission? No, you're talking about you're talking about a piston. The piston is actually what squeezes the clutches. So the piston is in the bottom of that drum. And if you remember right, you had to crank that thing down. You had to squeeze that spring. You had to take a big snap ring off and pull it out. Yeah, that's after you pull all your clutches and your fibers and steels out. Pull those out. You squeeze it. You got that special fixture over there. You push that thing down. And then whenever you take that piston out the bottom of that bore, that's what that's talking about. The piston is actually the part that moves and applies that clutch pack. And so you actually, yes, you do have to take that return spring out. And that's what Mike Chancellor, when he used to build these, whenever I was working with him back in 1977, he could pull a 350 turbo hydromatic out of a Chevrolet or one of the GM cars. He could take that thing apart and put it back together with all new clutches and seals and everything, and have it ready to put back in the car before the torque converter cooled off. That's how fast he was. But the thing about it was, he would leave about, if he had a guy that wanted to be a sort of a hot rod nut, he would, you know, you'd have that little row of springs all around there, he'd leave about half of them springs out of there. And that would make it shift firmer, you know, because those springs are made to cushion that application, and so he'd leave some of the springs out. And I said, you're going to leave some of the springs out of there? You know, it bugged me to see somebody putting something back together, because I didn't know that automatic transmission in them days, you know, but he was the guru, you know, on them things. But all right, let's see, number 7, the clutch pack cannot be modified. That's false. I just told you it can be modified. Yeah. You know what I'm saying? All right, some clutches use single-sided friction discs.
True.
That's true. Yep. The clutch housed in the transmission. The clutch is housed in the transmission or transaxle case. That's true. Now some of these, like let me ask you this: if I've got one that's got the big fibers with the teeth on the inside and they're on the outside of a component, and the steels are splined into the transmission case, what is the job of that particular clutch pack? It's basically like a band. It does the same job as a band. It's a brake. It stops something. See, it makes something one with the case while the reaction is going on inside that part. So if you see one that's got, like a lot of times on some of these transmissions, you'll see when you pull the pump off, the pump's got a piston built into it, and you'll see some clutches right under that pump that are splined to the outside of the case, and they do the same job as a band. So there's a bunch of different ways you can make things happen in an automatic transmission, you know. All right, let me see here. Plate clearance or piston travel measurements must be made after installing the clutch assembly. That's false. You don't install it, you don't make them then, you don't measure the piston travel there, you wait, I mean, you do it while you still got it on a bench before you put it in there. The leading cause, hey Bob, come here buddy. Benny. Now don't let our air conditioning out because we like to be cool. We like to cool down. This is the parts for your Ranger right here. Hold on buddy, I'm going to have you put this stuff on my desk. Okay. And there's that AC switch. Where's that AC switch at? Make sure them guys know where it is. It's a little thing. Where is it? In a bag or something? It's in a bag. All right. That little switch that goes in the back of your AC compressor, Daniel Gonzalez. That little switch that goes in the back of your AC compressor is there too.
Bag up. Okay.
All right. I have to, when I get this ticket signed, we'll be good to go. Supply. All right. Put the ones that are mine on my desk, and I appreciate your time.
Yes, sir. Appreciate
All right. Now then, let's see what we got here. The leading cause of joint failure is boot contamination. The leading cause of joint failure is boot contamination.
Yes.
No, it's actually when it's busted. And when it busts, there's a bunch of dirt and grit and all that kind of stuff get in there.
That's the same thing.
Boot contamination?
That's like a-
You want me to get dirt on the outside of it? It's going to mess it up? I don't think so.
Oh, I thought you meant.
Second rate amateur. All right. Number 12.
I'm thinking it's already busted.
Okay, GI, AAR, and NTP are variations of the Rosetta CV joint. That's false. Outer CV joints wear at a faster rate than inner CV joints. That's true. Now, what's the purpose of the outer joint? What's the outer CV joint there for? And it enables it to turn while the whole time having the same resistance. You know, in other words, if you try to turn a drive shaft, a regular drive, you like the little cross, you know, joint drive shafts like we got here on the table. If you try to turn one of them too sharp, it gets hard and easy and hard and easy and hard. You ever notice that? Like if you got a wiggler on the end of a long extension and you're trying to turn it, it'll bolt, you know, the socket jumps off and all that. So if you've got a constant velocity joint, though, it's one of them kind. It's just got the socket's got a little ball in it, and it runs real smooth no matter what angle. Now, what's the inner joint there for? One of you guys, I told you this yesterday because you were working on the CV axle on the bench.
Oh, yeah.
Jeremy, the inner CV joint does, what's the purpose of it? What does it do?
Plunge.
It plunges. Why does it need to plunge? Steering geometry. As it goes up and down, it's got to get longer and shorter. Do you have anything like that on a regular two-wheel drive Chevrolet pickup? Yes, you do. Think about it. The reason you have to, the drive shaft has got to get longer and shorter on a regular truck too, because of the same reason. As the rear end's going up and down, the geometry is changing. And so where does it do its plunging?
Transmission.
Right there where that long spline's going into the back of the transmission. See that? It's that long, and it's actually going in and out on them splines. And those splines are really supposed to be greased with Teflon grease, so it'll do that smoothly. Got me? All right. Inner and outer CV joints move in the same way. Is that true?
No.
That's false, isn't it? The most common CV joint design is the tripod joint. That's false too. The inner CV joint is designed to plunge in and out.
True.
That's true. The cross groove CV joint is commonly used in European vehicles applications where space is limited. Cross groove joint. This right here, I had this CV joint laying up here for a very long time. This one right here, that's a kind of a cross groove joint. But some yo-yo come over here and was sitting in my chair playing at my desk. That happens a lot for some strange reason and all that. I had to run Zach and him out of my office one day because they were sitting in my office rooting around in my desk drawers, you know. Nobody would like that.
Wait a minute, we were getting something out of it.
No, you were sitting in there playing that one day.
Wait a
All right,
minute,
now right
that's
here,
not playing.
see that? Right here,
Nah.
that little joint right there, somebody took it apart, and I don't know what they did with all the steel balls, but there's only 2 steel balls left. Not that it's a big deal, but that's from like a Volkswagen Rabbit. And these right here were bolted in there with these 6 bolt holes, and they had a little 8-point head bolt on there, and they would kind of come loose. And sometimes I was driving along one time on a Volkswagen Bug. They had some of these on the back axle, and it came loose from the bolts all worked loose. It came loose from the back axle. Of course, then it's like your speedometer is like a tack, you know, because your differentials like you're spinning a wheel or something. And so I'm under this thing, and it's hot, and I'm trying to feel under there, and it's night, and ain't no moon. And this is a strange story. I'm under there trying to feel these things and get them back in on my fingers by feel, because I know what's gone wrong, you know. And I'm wearing some kind of nice clothes too, but I'm a little disgusted because this has happened to me. So, and it was fairly common on those Bugs, 69 and up, they do this. So I'm trying to put it, and a trooper stops. Now listen to this. He's an Alabama State trooper. He pulls over, and I guess this was in about 1976. I don't know, a long time ago. And I'm laying there, and he goes, "What are you doing under there?" And I said, "I'm trying to put this axle back in here that has come off. So I'm in the grass over there." And I said, "Do you have a flashlight?" He says, "No, I don't have a flashlight."
Okay.
Wait a minute. What's wrong with this picture? Is a trooper without a flashlight? What you gonna do if you stop and give somebody a ticket? You can't look at their driver's license and shine the light in their eyes if you ain't got one. You know?
Hey, can I borrow your flashlight?
He may have not wanted to loan me his flashlight because he thought I wouldn't give it back or something. I don't know. Of course, he had a gun. But anyway, that's a true story. The guy told me he didn't have a flashlight and he was a trooper, you know, with all due respect. Okay, now we got, it's easier and less costly to use the ball and cage design rather than a spider assembly in a CV joint construction. That's false.
Hey, you never really, 4, 5, and 6, I never really got the info to do on that one. Like,
warped or worn or warped drum surface can be visually inspected. What did you guys get on that one?
false.
False. Why did you miss that? You were talking, I get it.
No, I wasn't talking.
Oh, I'm sure. All right, now 5 was, 4 is a roller clutch is a two-way clutch. What's that?
False.
That's false. And 6, the piston return spring must be removed before the piston can be serviced.
True.
That's a true B. We're true on that one. All right, you got it. Okay. Now let's move on to powertrain fundamentals, test 6. Unless I get started talking about something, we may actually have a slightly longer lunch today. But I can usually find something to take up the time. I have stories to tell. Okay, PM sensors measure the speed and position of rotating parts. What's a PM sensor? What's PM stand for?
I do. There's too many acronyms, I can't keep up.
That's not really an acronym. An acronym spells a word.
Oh, yeah.
Oh, yeah. All right, what you got here? What's a PM sensor?
Abbreviation?
Prime Minister or no?
Prime Minister?
Permanent magnet. How about permanent magnet? Okay, so tell me how permanent magnet sensor works. This is a class. We're supposed to be learning. Use your words.
I have no idea.
You've seen me draw this picture before. You could make a permanent magnet sensor. You really could. All right, so I'm gonna get me a magnet that's shaped like that. Right? It's a cylindrically shaped magnet, and I'm gonna wrap lots and lots of rounds of wire around it. Wrap round. Leave the end of the magnet exposed, and I'm wrapping it real tight. And I'm wrapping it real orderly. You know, just not just screwed up like that. All right, and then I'm gonna come off of that with both ends of that wire. And then I'm going to measure right here for those two, like I'm going to have it in a connector. And if you take an oscilloscope, right there, and you've got a toothed wheel, you know, that's going by that magnet. That goes by that magnet. What is it that happens? Whenever this goes by, you've got a shifting magnetic field. Every time that magnetic field, this is a ferrous metal part, and every time that magnetic field shifts and becomes a part of that, because that magnetic field is basically going to be up here in this area, and then it's going to shift down to in this area right here, and then it's going to shift back up there. And every time it sweeps across those windings, it's going to create, you know, a signal. You got me? Huh? Every time one of those teeth comes across there, you got a tooth and a gap and a tooth and a gap, and it goes up and down and up and down, and that's a permanent magnet sensor. That magnet never loses its magnetism. You got me?
Yes, true.
Yeah, that's basically measures the speed and position of moving parts. How can it measure position and speed, though? I'm trying to get you to think outside the box. Listen to him. Did you hear what he said? Say that louder.
A tooth missing.
A missing tooth. How about that? Yeah, it knows the position. If it comes past a missing tooth, the waveform is going to have a taller spike in it. Yeah, there you go. See, we got to burn this stuff in, because you guys are, you know, I don't want second-rate amateurs leaving out of here. The resistance of a PTC thermistor increases as the temperature it monitors decreases. What's a PTC thermistor? Huh? Positive temperature coefficient.
That sounds good to me.
Positive temperature coefficient.
Yeah.
All right, now what's the difference between a PTC and an NTC?
Negative.
Yeah, one's positive, one's negative. That's good. You picked up on that. No. So what makes this one here different from that one?
One's positive, one's negative.
The positive, but why do you call that? What usually happens if you heat something up? Does its resistance increase or decrease?
Decrease.
Think about it now. Your starter cable gets hotter, it's going to have more resistance in it. The hotter something is, the more resistance it's going to have. Now you can also, it's like, for instance, if it's positive temperature, like a bulb, listen to this. You remember when we were in electrical, you take this light bulb and you measure you ohm it out, and you say it's got, you know, half an ohm of resistance or something like that, or just very little. All right, and then whenever you do the calculation using your Ohm's law, when that light bulb's burning, you find out when it's burning, it's got like 6 ohms of resistance. But when you switch it off, if you measure it with an ohm meter, it's only got like a half ohm. It's a positive temperature coefficient device. Because the hotter it gets, the more resistance it has. And that's what you expect. That's what, remember that. The hotter it gets, the more resistance it has if it's positive temperature, more coefficient. Now, what do we use this negative temperature coefficient? They have to be designed that way. Those little thermistors that are your engine coolant temperature sensors and your intake air temperature sensors and your transmission oil temperature sensors. The hotter they get, the lower the resistance is. And what happens when the resistance goes low? The voltage that's being fed to that is being shunted to ground through that resistor as it goes down. And so the voltage is going to drop as it gets hotter. So with that in mind, let's look at our engine coolant temperature. Let's look at an engine coolant temperature sensor. Okay, if we look at the voltage on an engine coolant temperature sensor, you got about 4.6 volts coming in because it's coming out of a current limiting resistor. All right, and whenever it's actually, part of that's going to be shunted to ground through here. Like if you unplugged it, you'd measure that much, right? You got your connector here, you know, you got your 4.6 here, and this is the ground. It's inside the PCM. All right, now this one right here, when that thermistor down there starts out with the engine cold, then, and this is plugged in, that 4.6 is going to wind up reading about 2.8 roughly. It can be up or down depending on whether it's wintertime or summertime. As you crank the engine up and the hot water around this, you know, in this sensor down here that you got it plugged into starts to flow across here and heat it up, you're going to see this drop. When it gets down to a point about 0.45, usually the fan comes on. But it's going to run around, you know, 0.6. And so, you want, long and short of it is, as the resistance decreases here, it shunts more of this voltage to ground. And it's causing that to go down. So you can look at your temperature. When I used to work at the Ford place and I ran into these pinpoint tests in their book that was leading you around in circles, you know, they would ask you, they would actually have stupid stuff in there, like I say, is it greater than 1 volt? I mean, is it less than 1 volt or greater than 3 volts? But they didn't tell you what to do if it was between there. You know, I mean, that kind of thing. You know, you go through all them pinpoint tests, you come right back where you started, and you ain't fixed a daggum thing. Well, after about a week of that, when I come back from EEC school, I threw the book away, and I started measuring voltages on good cars, writing them down. And when I'd get I mean, that's when we didn't even have data stream. And when I'd poke that thing, I mean, I got where I could back probe that sensor, measure that voltage, and say, I know I'm not supposed to see that right now, this is a bad sensor. So on and so forth. Okay, now let's look here. So positive temperature coefficient thermistor, actually, what's that? Number 2 is false, because it's going to go the other way. An analog signal continuously and smoothly changes in what? They didn't say anything. That should be a blank there, shouldn't it? What two things change in an analog signal? Okay, we talked about that too.
Frequency?
Huh?
Frequency?
That's a good, yeah, that's part of it. That's a good thing. Frequency. All right, this right here, how many of these you have during a given amount of time? That's frequency. How tall they are is what they call amplitude. So the analog signal, yeah. Now, I mean, I'm talking about on a sensor. Now, what else? What's the difference between analog and digital?
Digital is like,
It's always either on or off, right? Typically, typically it's on or off. And
The makers with the Pontiac is out there.
Pontiac.
The Buick inside.
Oh, she needs
In the
to
door.
get her, grab her.
Yeah.
Yeah. Hey, girl, you got your key? Oh, it's the look in there in my office, and you'll probably find it, and then you'll see Stacy, and you'll be good to go.
You'll probably find it.
Hey, can I, leave the other one here?
Yeah, for what were we gonna do that? I forgot. Huh?
Skipping.
Oh, it's slipping or skipping?
Skipping.
Skipping? Yeah, we can do something with that. I got guys that just love to work on those. All right.
I don't know what it doing. It wasn't doing that.
Huh?
This morning.
Yeah. Oh, shoot. Okay. So I started skipping this all of a sudden just now. Okay. Well, leave it here, and we'll see. Yeah. Well, I'll make a work order and get your mama to sign it. It'll be all right.
Okay.
All right.
Thank you.
All right then. A discolored steel ball. Very nice. Okay. Now then, somebody heated that up with a torch. That's what they did. All right. Now then. But anyway, analog is basically like a throttle position sensor. If you look at that throttle position sensor, it's going to be up and down, up and down. Digital is going to be up like that. So an analog continuously, smoothly changes in and the voltage is going to smoothly change. So anyway, that's a dumb question. It's not finished. I don't know who typed that question. It wasn't me, but that should be true. Automotive computers and control modules use analog signals converted from digital signals. That is absolutely correct. Excuse me, back up. I said that wrong. Digital signals, they use digital signals converted from analog signals. I read it wrong, but that way it's worded is false. But basically, that's just backwards is all it amounts to. Is they're going to use analog signals. When the analog signal goes above a certain voltage, it's going to say, okay, that's on. And when it goes below a certain voltage, the computer says, okay, that's off. The computer has to convert analog signals to digital signals to work right. Because the computer does not like an analog signal.
Analog to digital,
Yeah,
not digital to
that's right. It's
analog.
backwards. This word's backwards, and I just, answered it off the top of my head like a bimbo. All right. The entire powertrain control module must be replaced if a change in programming is needed and the programmable read-only memory is not replaceable. That's number 5. That's true. If you can't replace, now I will tell you on the GM cars, for years you could replace just the prom chip, and they had a little cowl pack in there. The little cover you take off the top of the computer, and it had a little centipede in there. You could pop that out, get another one that was the right one, stick it back in there. That was part of your programming. And I've actually seen them where they would be like a 91 Chevrolet pickup we worked on here years ago. It's one of them situations where they bought an engine from the doggone parts house, and it was running like a dog, and we adjusted the valves and fixed it. And then there was something wrong with the throttle body too. I can't remember. But I borrowed a throttle body I had off a shelf in there and put on there, and it ran better, but it still had a little bit of a rough idle to it. And the boy was looking at it, and he goes, well, I still don't like it rough idle. And his daddy told him, he said, that truck was doing that before you ever changed out that motor. He said, before you did anything to that, it was running the same way. And so I got a prom chip out of an old engine computer I had back just to stick in there and see what it would do. Smooth as silk. And I said, that's out of a V8, and this is, a V6, and this is a V8. He goes, I don't care, leave it in there, it runs too good. But anyway, he drove away from here with that on there. But one way or another, the prom chip is something you could replace on some of the older GMs. But you got to replace the whole engine controller. Starting in about 1990, 94, OBD2 came out. Everything OBD2 is reprogrammable. It's got an erasable prom chip. So you juice it up with 18 volts, wipes out the program, writes a new one in there if you got the right calibration files. So that's sort of going away, unless it's a really old one. We did replace an engine controller on that 93 F-150 the other day, that red one that was in here, because it had got wet, and you couldn't do anything about that. A shift solenoid can be tested with a DVOM or by air testing.
True.
That's true, but you really need to do both. You can test a shift solenoid with a DVOM, and it can pass that test and still not be good. I like a test that's a go, no-go test. If I test something, and I know for instance, this little fan test I'm always talking about that we do, where you hook up that light in series with your fan, you turn it through, if that light ever goes out, end of story, the fan's bad. But sometimes you can check something, and you may get an indication from that particular test that something's bad, but another test will differ with that. So you know what I'm saying? Injector flow testing that we were doing back after we, Ford got us this injector machine, and you could flow test injectors. And I found out that I could flow test injectors, and they on an engine that was running bad, and they would flow perfectly fine. I would clean it; they'd flow the same, but the car ran better. And so I stopped using that flow test because it didn't mean anything to me. It was not a good test. We also had a charging system machine that we got from one of the tool suppliers that we could hook up, and it would tell you that it had a bad diodes in the alternator, but unless I hooked an oscilloscope up and verified that, I didn't trust that machine. So it's always good to come up with the best way you can test something so you can absolutely know something. The better data that you can gather that's the most reliable is the one that, sometimes you got to check several different things and see if they all point in that one direction, All right. Vehicle sensors produce an output signal that can either be analog or digital. That's true. OBD1 technology can diagnose and detect only system failures and system degradation. That's actually false. A lot of the OBD1 vehicles could actually do rationality checks and this kind of thing, and we talked about that in engine performance too and all that. Serial data can be used when a no-code condition occurs. That's true. What's serial data? Huh? That's That's your data stream. You know when you go down to data stream, like you were looking at earlier, you're looking at all the readings on your down to a serial data.
Think like a Moses.
And why do they call it serial data?
Don't answer that.
I just love it when my phone rings right now. Hello? Hey.
With a serial table underneath it.
Yay! Okay. Well, let's see about.
You were asking Jeremy about that. Maybe
I was not asking Jeremy about his transfer case. Well, they couldn't get the drain plug out of that transfer case. That's why I was asking. We need to figure out how to do that. All right. Then you go down here. Which one are we on? First step. Yeah, I'm going to drain the lubricant myself after I'm up there looking at it. The outside of a transfer case should be cleaned before disassembly. That's actually true. I'd clean that sucker. I don't want dirt getting all there. Transfer case is usually filthy. When overhauling a transfer case, replace all bearings. Now, I've got transfer cases over there that you guys have got worksheets you're supposed to take a transfer case apart and put it back together. Ain't that hard. It ain't like doing a transmission. You know what I'm saying? But when you put it back together, you need to make sure you do it right. You don't just cram it back together. A lot of times when a student's doing something, they'll say, well, if we can get the cover back on here before he sees me, I'll be done with this sucker and I can get it right, you know. But it needs to work, you know. Even if it doesn't work when you start on it, it needs to work when you're done. You got me? So if you put it back together and you can't show me that it works, you'll just have to start over. That's what it is. So make sure you do it right. When overhauling a transfer case, replace all bearings, whether or not they show any signs of wear. That's false. Just replace them if they show wear. When reassembling the transfer case, check critical clearances with a feeler gauge, micrometer, or dial indicator. That's true. A stepper motor moves in its output shaft in increments such as quarter turn or half turn. Now, what is a stepper motor?
Isn't that in a transmission? Or no, that's
The stepper motor, what's the first place you can think of where there is a stepper motor? What about on the General Motors cars that have a idle speed control? It's got that little dumpy little short idle speed control. It's got like 4 wires going to it. And what that thing does is, and this is a generic way that they work, it'll have 1 wire that's hot and then it'll walk the ground just to the other 3, like this. And it's turning the little screw that's in the middle, using its little armature, and it's screwing this little thing out and back in. And so that's why you'll see on your scan tool, it'll say it's 180 steps or 45 steps or whatever, you know. And we used to have a cool little box that has electronics in it. We could check the Jeep ones, unplug it from the wire harness, plug it in, and you could push it this way, push it the other way. But it's not really it's not what you would think about a reversible DC motor. It's actually it can stop in like any of 8 different places. It can move just 1/8 of a turn, or it can move around and around, but it can stop anywhere it wants to. That's what. It's pretty cool how that thing works, and they use them for different things. Driveline wrap-up, I would say driveline wind-up, is used to describe the proper load on the drivetrain and universal joints when the vehicle is on slippery surface. That's false. Driveline wind-up is when you put it in 4-wheel drive by accident, you back it out of your stall, and it goes and it stops, and you got to pull it back forward and unwind it. I've had that happen before on Bronco. Using a lift kit to raise a vehicle changes the vehicle's center of gravity, but not its driveline angle. That's false. Think about that. You've seen that. Driveline angle is going to change, isn't it? You know, drive shaft. You know, these people, one of the things I never understood is these people raise these things up with a huge lift kit, and they got the truck this high off the ground, but that differential chunk is just as close to the ground as it ever was. They ain't helping the ground clearance none. You know what I'm saying? I mean, except with bigger tires, it'll help a little. But I mean, they got the truck, way up high, but you look, and all of the other hardware is about as close as, and it can still get hung up on a stump or something. It looks cool driving down the road, I guess. Burns lots of gas. I mean, it's everybody's own business. One of the things I always said though is if you found somebody that had let's say a '69 Camaro that was all dolled up and everything and had all kinds of aftermarket junk on it, and then you found one that had been sitting in somebody's garage that had never been touched, and they were both the same price, you'd probably buy the one that had never been touched because you'd want to do your own thing with it, right?
Yeah.
You see what I'm saying? The other one that's already been chopped up and had the wire harnesses all jacked out of shape and had the exhaust all chopped up and had somebody else's motor put in it, I don't really want that one. I want the one that hasn't been touched so I can only modify the parts of it that I want to modify. Maybe a slick paint job or some cool looking wheels. I don't want the dumb little wheels they used to have that were like this big around, and I'm not really into the wheels that are like this tall, or anything like that. I mean, I kind of want some that are good looking wheels if I'm going to do something like that. And of course, my car's got stamped steel wheels with plastic hubcaps. You can tell how important that is to me, right? Okay, viscous couplings are tested with a torque wrench. Well, to begin with, that's true. I want you to tell me what a viscous coupling does. What's the purpose of viscous coupling? I've talked about these before in here. Did you guys forget? I've got to strengthen some neural pathways here. What?
What is 17?
17, that is the age just before you become legal. All right, let me see here. 17, a stepper motor moves out. That one's actually false. All right. There you go. You got that? Viscous couplings. On a, well, we were talking about driveline wind-up, right? Like when you put one in four-wheel drive that ain't got a viscous coupling, it's going to wind up if you're not on a slippery or muddy surface. If you're on hard pavement, you know, you're going to wind everything up. Yours are like that. However, if you got a viscous coupling, you've seen these vehicles that are like all-wheel drive, sports car things, or even on,
BMW.
or these hot rod cars that are all-wheel drive. The cool thing about an all-wheel drive car is, and I'm not telling you need to drive irresponsibly, but the people that drive those things love them because they'll take them 15-mile-an-hour curves. You can hit them at 70, and the thing just sticks to the road like glue. It's amazing what kind of traction and how the handling you get with an all-wheel drive car. But it's always pulling on all four wheels. But it's got to have a viscous coupling so it doesn't wind up. And that viscous coupling, the closest thing I can compare it to is this. It's actually got resistance that's delivering some torque to all the wheels, but it also keeps them from winding up because there's some of this slippage here. You got me? But now the viscous coupling is going to be, it's going to have a bunch of, it's going to be about this big, and it's going to have shafts going through it. And basically, there's always torque being transmitted, but it also lets it keeps it from winding up. You see what I mean? There's not any actual connection other than through this thick glycerin stuff that these blades are cutting through. That's what a viscous coupling is all about. And so I wanted to make sure everybody understood what I was talking about. Sometimes if you guys want to ask a question, I'll say something about a viscous coupling. You'll say, well, I got past that question, but I don't know what a viscous coupling is. You know, people won't ask, particularly if it's getting close to lunch and they want me to shut up. You know what I'm saying? That's really funny. All right, so let's go, and I will see you guys back here at 1.